Okay, so today I really wanted to talk about solution types in quadratics. And with not knowing complex numbers, you I've taught you how to do two real solutions, one real solution. Um, so two real solutions and one real solution. Okay, and the next one I've taught you how to do was that there were no real solutions, but now that you understand how the conic section looks and how it's three-dimensional, you can assume that since it doesn't have two two real solutions, that doesn't mean that it doesn't have two complex solutions. So that is your next type of solution. Okay, so two real solutions. You should know what this looks like. Two real solutions means that there is a positive under the or under inside the square root or the radical sign. Okay. That also means that it has two distinct x-intercepts, and we know that the other terms that you can think of for solutions is x-intercepts, the zeros, the solutions. So that's you know this way. And an example of that would be y equals x squared minus 2x minus 3. That would be an example of that, and you can graph that at home, and so you can see those two real solutions. Now, the other one that you know is one real solution. Okay, one real solution, whenever you're doing the quadratic formula, there will be a 0 inside the square root. So you will end up with the square root of 0. That will also have one x intercept, which you can assume that one x intercept will be the vertex. Okay, so that an example of that would be y equals x squared minus 6x plus 9. Okay, that would be an example of one real solution. Okay, now the one that we haven't talked about just yet, now we've discovered it today and kind of seen a 3D model of it, or interactive model of it. I want us to talk about two complex solutions. The two complex solutions, that means that there is a negative inside the square root. Okay, and there are no x-intercepts. Okay, now I do want to give you an example of this. So here's the example. It's going to be x squared plus 2x plus 8. And you're trying to find the solutions, so it's going to equal 0. What I suggest you doing is, you should know all the ways to solve a quadratic equation, but the foolproof method that's going to work every time is the quadratic formula. So if you just get used to using the quadratic formula, but recognize the others, I think you'll be just fine. So you say you've got negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 8 all over 2a, which is 2 times 1. Okay. So when you're doing this, you've got negative 2 plus or minus the square root of 4 minus 32. Okay. All over 2. And you're left with negative 2 plus or minus the square root of negative 28 all over 2. And you know that you can simplify a radical. So if you can take this 28, you can do some prime factorization, 2 and 14, and then 2 and 7. This 2 right here. So you'll have negative 2 plus or minus the square, plus or minus 2 times the square root of, is still a negative 7 though, because you didn't factor out that negative. So it's still a negative 7 under there. So now what we can do is you can, because these three are all the same, they have 2 in them, you can divide this 2 out. So you've got right there. And what is negative 2 divided by 2? Well, it's negative 1 plus or minus the square root of negative 7, which can be rewritten as negative 1 plus or minus I times the square root of 7. Okay, that is your example of 2 complex solutions. Now that I think you'll have a better understanding of how these solutions fit within a quadratic. Okay, thanks.